Hey folks, in the previous video we discussed how UIKit render loop works. Let's move to SwiftUI now. You can say UIKit is great, but actually SwiftUI is the future. But don't hurry up to bury UIKit. As you will understand soon, it's still very useful to understand how SwiftUI works under the hood. SwiftUI is declarative and data-driven UI framework. It conceals its entire render loop process behind the body of the view, provided to us for constructing the views. Structure of the body defines both layout and content of the view. Let's try to figure out what stands behind the body. I guess important disclaimer here would be that things we will discuss next are not documented and we have no access to the actual SwiftUI code implementation, right? So I will try to give you a guess how it can possibly work to help you build your own mental model about it. Similarly to UIKit, SwiftUI has its view tree. However, in contrast with UIKit, where UI view is an object, views in SwiftUI are structs, making the view tree ephemeral. Views can be recreated whenever the state changes in body is reevaluated. To determine when to reevaluate the body, SwiftUI uses the attribute graph. This is an internal component that builds a dependency graph for your data and its associated view tree. Unlike the view tree, the attribute graph is persistent and remains even when the body re-executes. With each new generation of view tree, SwiftUI performs a diff against the current state of the render tree, efficiently applying the necessary changes by adding and removing nodes from the render tree. Chris Eidhoff refers to the attribute graph as a render tree, to simplify the understanding of the concept. This makes sense to me as well because it serves as sort of source of truth for rendering. Additionally, it's a fitting analogy with the render tree in UIKit. To provide some structure for view render loop of SwiftUI, we can separate render loop process into three phases: evaluation phase, layout phase, and rendering phase. Evaluation phase goal is to construct or update render tree from new view tree when state is changed. So let's imagine for this example that state was changed. After that, related render subtree is invalidated. After that, new view tree is constructed and render tree is updated. I can recommend you this post from Chris Eidhoff called A Day in the Life of SwiftUI View if you want to know more about how render tree works. Next, layout phase, proceed top down. Parent views offer their available space to their children, which decides their size based on that. Finally, parent places child in parent's coordinate space, usually in the center. Layout phase is very well explained in the post from Paul Hudson and in King blog. Once layout phase is completed, views are supposed to be rendered on the screen. The exact process SwiftUI uses for rendering remains uncertain. Yet it's reasonable to assume that SwiftUI relies on underlying UIKit, core animation, core graphics, and metal to do that. And keeping that in mind, there should be some kind of mapping between SwiftUI view tree and UIKit view tree. In this case, rendering phase probably can be better called mapping to UIKit phase. We will try to confirm this assumption in the next part of this video. Okay, how about exploring some real details we can uncover from the Xcode debugger? Let's create a new SwiftUI project in the Xcode and try to see what happens before body is called by placing a breakpoint inside the view body. We can make a few observations here. AG graph on this screenshot represents the attribute graph we previously mentioned. And these unnamed symbol rows are the parts of the SwiftUI code which remain hidden from us by Apple. However, our primary interest lies in the lower part of the stack trace. There we might observe something quite intriguing. Looks pretty familiar, right? It's just like the UIKit render loop we discussed earlier. This occurs in a pure SwiftUI application without a single UI view added by us. It actually proves that SwiftUI incorporates UIKit and core animation under the hood, inheriting plain old render loop we previously discussed. During each run loop iteration, when the layer hierarchy traversal takes place as a part of the implicit CA transaction layout phase, SwiftUI does its render loop starting from the layout sublayers method call of the UI view. So SwiftUI view hierarchy is actually hosted by UI view subclass object called UI hosting view. The same way as for UIKit in SwiftUI, views will be rendered on screen only when the implicit CA transaction is committed. As the layout phase of transaction, SwiftUI render loop is happening inside UI hosting view layout sublayers method. You can observe connection of SwiftUI and CA transaction with simple example. We can add CA transaction begin method in the on-tap gesture. I'm strongly recommend you not to use CA transaction with SwiftUI in your codebase, and it's just a demonstration example just for fun. When you call CA transaction begin, a new transaction object is created and pushed into shared transaction stack. So if you don't call CA transaction commit after that, you simply kind of break the transaction stack because of the way how nested transactions work. No layer 3 changes will be committed to the render server after that, so in our example we will not see neither yellow or green colors update on the screen after tap. If we try to build similar example with main thread blocking and explicit transaction as we did for UIKit, we will discover another important aspect of SwiftUI. In the similar UIKit example, we would see yellow color in the middle once explicit transaction is committed before main thread had been blocked by sleep method. But in SwiftUI, it seems to not work in the same way. But why? Let's remember how CI transaction works. It commits the new changes of layer 3 to the render server. But in our SwiftUI example, we didn't do any changes to any CA layer inside our explicit transaction between begin and commit methods. We only changed the state of SwiftUI view, and it needs to do another SwiftUI render loop to actually rebuild view tree and render tree to apply changes to underlying layers. This is actually why none of the changes after the body evaluation or onAppear call aren't rendering instantly. At the moment of body evaluation or onAppear or onChange methods, underneath CA layer properties are not yet changed, so at the moment nothing to commit yet. We need to do a full SwiftUI render loop first to change underlying layers that will be committed with implicit transaction and eventually rendered. We can try to extend this example a bit. We already know that in the root of SwiftUI hierarchy lies UI hosting view. It is UIKit UI view and it has its CA layer under the hood. There is no way to access UI hosting view from SwiftUI code, but if we set UI hosting view to global variable from UIKit side, for example, we can access it inside tab gesture. Never do anything like that in your production code, but if we change the background color of hosting view inside the explicit transaction on tab gesture, it shows us that explicit CI transaction started to work with layer 3 changes as expected, even inside SwiftUI code. But it also shows that it makes no sense to use explicit CI transaction in SwiftUI views once you usually don't access core animation layer 3 directly from SwiftUI, and you shouldn't. We used UI hosting view in the last example, but we didn't talk about it much so far. Let's discuss it next. If we look in Xcode view tree structure while debugging a new UIKit project, we will see this in the root of it. So it's default view controller and several UI views between it and UI window. And in the root of a new SwiftUI application, you will see exactly the same structure, but with hosting view controller, with UI hosting view inside that hosts SwiftUI content view. All of SwiftUI's view tree is hosted by UI hosting view, controlled in turn by the UI hosting controller. Any changes to the view structure applied to UI hosting view and its subviews by SwiftUI internally are rendered by the usual core animation render loop we discussed earlier. When you add new SwiftUI views to your content view body, SwiftUI will add UIKit subviews to UI hosting view if needed. I mentioned if needed because not every SwiftUI view corresponds directly to a UIKit UI view under the hood. There are multiple ways graphics can be rendered in SwiftUI. SwiftUI can internally create UI view to display them, or it might not. For instance, while some views like vStack participate in layout, they don't have their own UI view under the hood. Let's consider simple SwiftUI content view as an example. Looking at the code, it's easy to jump to the conclusion that the resulting UI will consist of vertically aligned UI stack view, which contains UI image, UI label, and UI text field. However, only part of those assumptions is actually true. Unlike CI layer within each UI view, not every SwiftUI view has a UI view behind it. Some SwiftUI views do utilize UIKit, although not all of them. In our example, we will see the following structure of subviews added to the hosting view. For image, it will be UI graphics view under the hood. It's private UI view used in SwiftUI for many elements under the hood. For text, it will be CG drawing view, special UI graphics view subclass for text drawing, and CG prefix help us to understand that core graphics is used to render text in SwiftUI as it was in UIKit. And last, text field, view host is used for it, which is actually UI view representable that we know from SwiftUI, and UI text field is hosted inside it. I will try to group all views based on the way they are backed up by UIKit. First is no UI view behind, like for layout or structure-based views like spacer, vStack, hstack, zstack, lazy hstack or lazy vstack. Second group is backed by UI graphics view, and it's for graphic-based views like color, image or divider. Third group is backed by CG drawing view class. It's subclass of UI graphics view for text-based views like text, button or text editor. Fourth group is the specific UIKit UI view hosted by UI view representable, like for example text field with UI text field inside, or progress view, slider or list. All other views are composition of views listed above. It's important to keep in mind that underlying implementation of SwiftUI views can change with time. I guess it's the reason why Apple keeps SwiftUI implementation private. They want and can change it with time, but SwiftUI API will remain the same. For now, SwiftUI mostly wraps existing UI frameworks like UIKit, core animation, core graphics, but in the future, if Apple decides to, they can deprecate UIKit without changing the SwiftUI APIs and rewrite the foundation of it. It is a very long way though, so UIKit probably will be there for some time. So now let's do a recap about SwiftUI. The body of the view defines both its layout and content. Behind the body, SwiftUI operates through a complex system involving view tree and attribute graph, also known as render tree. SwiftUI has a view tree, but unlike UIKit, views in SwiftUI are transient structs. Views are recreated when state changes, and SwiftUI optimizes this process by leveraging the attribute graph to track state changes. The SwiftUI view render loop involves three phases: evaluation phase, layout phase, and rendering phase. Evaluation phase includes rebuilding view tree and render tree, diffing and body evaluation. Layout phase goes top-down. Parent views offer their available space to their children, which decides their size based on that. We don't know much about SwiftUI rendering phase, but we know it relies on underlying core graphics and core animation and Metal for that. By relying on UIKit and core animation, SwiftUI internally uses implicit CI transaction for managing changes to the layer tree. Although you don't use CI transaction directly in SwiftUI apps, the framework internally still uses core animation and CI transactions for drawing and animations. Together with the render server, core animation is very foundational to iOS apps. SwiftUI View Tree hierarchy is hosted by UI Hosting View, the private UI view from SwiftUI, controlled by UI Hosting Controller. Some SwiftUI views internally use UIKit views, like UI text field used and hosted by text field. But not all SwiftUI views are mapped to UIKit views internally. Thank you for your time and see you in the next videos.